Okay, so this video is looking at lesson 2, which is cyber security. I'm just going to share my screen so that you can see what it is that I'm on about. Okay, so basically what we're going to be looking at in this lesson is passwords and encryption. So a little bit more about passwords than we looked at in the previous lesson, and looking at encryption as well. So as I said, it's difficult to explain something so simple as a password sometimes. So there's just some information here on this slide explaining what a password is. Pretty much what I said in the last video. The fact that it's used to prove a person's identity to allow them access to some data. It's normally used in conjunction with the username. It also there talks about the different complexities of passwords, but you'll be able to have a read through and you should know most of that already anyway. So the problem with passwords is that they can be guessed. Now often computer programs will try the most common passwords until it finds which one it is. Also there are programs that will run through every possible combination. So you're looking at using a supercomputer to do that, but actually if it's some really sensitive data that maybe another country wants to get hold of, then it might be worth doing it, and that's known as a brute force attack. And you're going to have to be able to, in the exam, calculate how many guesses it would take as a maximum in order to guess a certain password, given different examples of passwords. So, as a rough guide then, this is how you could calculate how many attempts it would take as a maximum to work out a password. So the way that it works is the attempts is equal to the number of characters that are possibly in that password to the power of the password length. So for an example, if the password was computer, that's 8 characters long. Okay, so we know that it's going to be to the power of 8. We also know this password that it only uses lowercase characters. Therefore, there are 26 possible characters because there's 26 letters in the alphabet. So we know, therefore, that it's 26 to the power of 8. Okay, and you can see that large number there that will tell you how many guesses it would take. But actually, if a computer was whizzing through those thousands of times a second, millions of times a second, that wouldn't take that long to guess. So if we had a different password here, such as computer1 with a capital C, we've now got a 9-character long password, so it's to the power of 9. But we've also got 26 possible lowercase letters, 26 possible uppercase letters, and 10 numeric numbers, so 0 through to 9. So that's 62 possible characters. And you can see there that that massively increases the number of attempts that it would take to crack a password. And if we were to include symbols in that, not that you would have to in the exam, that would be obviously an even larger number. So moving on to encryption. Encryption is basically when we jumble up some text, for example, using a key, so that if you don't have the key, it'll just look like gibberish. You won't be able to understand what the writing says, unless you've of course got the decryption key. Now, one way of encoding binary data, which obviously even letters and that are all binary data really, one way of doing that is using the XOR logical operator. Now, I don't think we've been through logic yet this year, what we've been off school, but we did go through it in year 8, so this will look familiar to you. But as a quick recap, what we've got here is we've got 2 inputs into our gate. Now, the logic gate actually looks like this if it's an XOR logic gate. So I'm just going to attempt a drawing, not quite like that. They should be curved, but never mind. And what we've got here is we've got our input A, our input B, and our output over here. Okay. Now what we're saying is if the electricity, if both of these switches A and B are off, 0 and 0, then the output will also be 0. With an XOR gate, if we have one of the inputs on, so in this case B, then the output becomes on, or a 1. Same if we swap it from A and B switched off, the output would be 1. However, with an XOR gate, which is different to an OR gate, if we have them both switched on, then the output switches off. So basically it has to be just one of these switched on for the output to be positive. So the way we can use that is like this. So if we had our original data here, 10101010, we could use this key, which is just a random key. It could be anything. It could be all ones. It could be anything. And we XOR them together. So if we have 0 XOR 0, the answer, the output is 0 because both of them are off. With this one, we've got one on and the other off. So therefore the output is positive. It's on. 0 0 is off. 1 0 is on. 1 0 1 is on. When we've got two ones, of course, it's off, and so on and so forth. So that then becomes our ciphertext. And unless you know this key, you can't understand what this means. What you can then do is use the key in reverse. So now we've got our ciphertext. We apply the same key, and then you get back to the original data. And you could have a go at trying that out just to see that it works. But trust me, it does. There are obviously a lot more complicated techniques that you could have a look at as well. SHA-256 and Blowfish, you can have a little look at those if you're interested in how encryption works in more detail. So you're going to be going through your OneNote, which should look like this, answering these questions, doing your brute force calculations. I would recommend using the calculator on your computer if possible, because then you can copy and paste the answer in rather than trying to write out all those numbers. And then you're going to have a go at doing some encryption as well. Right, as always, take care. Hopefully you're getting some work done, but don't stress yourselves out if you're finding it difficult. Just do what you can do. Things are going to get covered again when we come back to school eventually.